Alright, so we are back by popular demand, and I know a lot of you guys enjoyed the previous vlog and you guys said you wanted more, and I was like, hell yeah, I'm gonna make more. So today we're basically just going to continue from exactly where we left off during the previous vlog. And I know you guys are probably asking why I haven't worked on this for a very long time. I think it's been like a month since I uploaded the last vlog. Yeah, I think it was about a month. The truth is that life has been crazy. Like, there's been a lot going on in school, life, especially at school. I've been searching for internships, so that has taken up most of my time, and I finally got an offer. Yes, thank you. I finally got an offer, so now I have more time on my hands to actually do stuff that I want to do, which is stuff like, you know, fixing my broken applications. So yeah, that's what we're gonna be doing today. This is going to be a realistic vlog, as real as it gets. We're gonna be coding together, fixing stuff together, debugging stuff together, because I know a lot of things are probably gonna break. I don't know if you guys probably watched in my previous vlog, I told you guys I don't really know C#. I have taken only one college class that taught C#, and I'm currently converting my applications backend from PHP to C#, which is some people might say is stupid, but I feel like it's the best way to learn. So I'm going to be Googling and ChatGPTing my way throughout this whole process. Yeah, so you and me both, we're going to be figuring all this out together. And also, if you haven't watched the previous vlog, I will highly recommend you go watch it. I'm going to link it somewhere up here, but I definitely recommend you go watch it. It's going to explain a lot of what we're going to be doing today, or a lot of what I'm going to be working on today. But since I'm a nice guy, I'm going to give you guys a brief recap of what we did in the previous vlog. All right, so this is what we worked on. Just give me a second, let me get this straight. All right, cool. So this is what we built during the previous vlog. We basically built the authentication logic for my application. The login app has two different options. You can either log in with your email or log in with Google. And if you're logging in with Google, Google kind of handles everything for you, so we don't have to worry about that. But if you're logging in with your email, we send your email to the server, which is .net. We check if the email exists. If it does not exist, we send a response back to the client, and the client sends you to the sign-up process. But if your email actually exists, what we do is we send a token to your email address, or sorry, the backend generates a token and sends that to your email address. And if that email sending process was successful, if it was successful, we send you a 200 response back to the client. The client then updates the UI, asking the user to put in the code the server sent to their email address. Simple. But if the email sending process was not successful, we're going to send a 500 response back to the client, telling the user that something went wrong, they should try again. Very simple, very basic. It definitely took a lot of time. I'm not gonna lie, it took a lot of time for us to figure this out during the previous vlog. But yeah, that's everything we worked on during the previous vlog. And I think I remembered saying we were going to work on the token verification logic and also the resend token logic in this vlog. Did I say that? I think I said that. That's exactly what we're going to be doing today. And you guys already know I love drawing stuff out before I build it. So I, of course, created a diagram of what we're going to be working on today. And there are two diagrams, right? There's a diagram for the token verification, and there's a diagram for resending a token. But yeah, the client basically updates the UI, asking the user to put in the token they got in their email address. Once the client puts in that token, it basically invokes the user enters token request, which basically sends the token and the email address to our .NET server. And what the server does is that it gets the most recent token inserted into the database for the email address we passed in when we make the request. So it basically takes this email, checks the database, gets the most recent token that was inserted into the database for this email address. Then it checks if that token is expired. Hold on, focus, come on. Let's go, you can do this. Sorry, this thing is having a hard time to focus. So once we get that token from the database, we check if the token is expired. If it is expired, we go ahead and send a 401 unauthorized with a message that says, can you see it? Token expired. But if the token is not expired, we go ahead and check if the token from the database matches the token we got from the client. If the token the client sent and the token we got from the database here, if both of them is a match, we go ahead and delete the token from the database and send a 200 response back to the client. That means the user is verified. But if the token doesn't match then our client isn't who they say they are, we go ahead and send a 401 unauthorized back to the client. But just an overview of everything I just talked about. The client makes a request with the token and email address, and we get the most recent token that was inserted into the database for this user based on the email address. We check if the token is expired. If it's expired, we still go ahead and send a 401 unauthorized back to the client with a message saying the token was expired. But if the token is not expired, we go ahead and check if the token we got from the database matches the token we got from the client. If it's a match, we go ahead and delete that token from the database so it doesn't exist anymore. And we send the 200 response back to the client, meaning the user is verified. But if that token doesn't match, it means our user isn't who they say they are. We go ahead and send a 401 unauthorized back to the client. Cool. I really hope that made sense, but let's move on. So this is the diagram for resending a token, and it's technically the same thing as this first diagram if we were sending the token initially. But the only difference is that if the user requested a resend token, it means that the server already generated a token that the user did not get, meaning there is a token already stored in the database for that user. So when we're resending a new token, we have to delete all the previous tokens for that user if they exist. So we're basically running a search query for all the tokens for this email address. If we find any token, we're just going to delete it. So that way, if we're verifying the token, we don't get the token that the user did not get. The reason why we're doing this is because when we're verifying the token, we don't want to verify the token the user put in against the token they did not get, if that makes sense. So we just want to delete all the tokens for that user in the database, generate a new token, same thing, send it to them in their email inbox. If that sending process was successful, we go ahead and store that token in the database, then send a 200 response to the client. The client updates the UI, telling the user to re-enter the token the server just sent to their email. But if that sending process fails, we go ahead and send a 500 internal server error, meaning there was an error, they should try again. Oh yeah, very simple logic, nothing crazy. Same thing with the verification logic. Nothing crazy at all. And for those of you guys who have been asking how I was able to create this diagram, and I know a lot of you guys actually asked that question, I used the Apple's Freeform app, which is a free app on iPhones, iPads, and also like MacBooks. If you have an Apple product, you definitely have Freeform. And this is what Freeform looks like. And what I did is just basically drag in boxes and arrows, including text, to just create a diagram that, replicates the logic I'm trying to perform. Very simple, nothing crazy. But just to mention, I'm actually a very visual person. Like before I implement anything or before I actually write any code or implement any like major logic like authentication, or if I'm trying to, request something from the database that I have to, process before sending it back to the client, I have to, create a diagram or a flow for it. Just that way, it just helps me visualize something before I actually start writing the code, if that makes sense. But because sometimes if I just go head first into, writing the code, it just saves me the time of trying to piece my thoughts together while I'm coding, because I've already, diagrammed it out, so I can easily just reference the diagram to kind of clarify any doubt or any confusion I have while I'm coding. It's just a good practice if any of you guys want to get into the habit of creating diagrams before you code. But yeah, right now I'm going to start writing the code for the token verification. Like I said, I don't think it's going to be something super difficult because of number one, I already drew it out, so I already know exactly what I have to do. And second of all, I don't think it requires any heavy database queries for one, and also there isn't a lot of logic going on. The only serious logic for the token verification I can see right now is just, making sure the token is not expired, and also making sure the token that we verify from the client matches the token that is in the database, and that is all. So again, nothing extremely crazy. So yeah, I will update you guys when I'm done. And I don't know if it's just me, but I actually prefer to listen to just one artist instead of a playlist when I'm coding. I feel like if there's one specific artist I vibe with a lot, I just prefer to listen to all of their songs than just listen to random artists on a playlist. But if you guys want me to make a playlist, a Spotify playlist for programming, let me know. I'm definitely going to do it because it's something I've been thinking about for a very long time, but I haven't had the motivation to do it. So if you guys actually want a playlist, I can come up with a very good playlist for developers. Trust me. Just let me know if you guys want it in the comment section and I'll do it.
Suddenly, the world I used to know, I see it differently. You woke me from a dream, now here's reality. Baby, baby, you are really hurting me. 'Cause every time you tell me I look good and that I'm doing fine, but nothing ever changes. And now I see, baby, you are hurting me. Stuck in repeat. Stop lying. I know you playing your part, but baby, it's breaking my heart. Is it over? How could I know? If you don't need me, just let me know when I go.
I swear, Parallels is actually pissing me off. Like, it is running so slow. I am this close to Hulk smashing this keyboard right now. Alright, so I'm done and I think I got it to work. The funny thing is that I haven't actually tested this out. I should have probably tested it before I hit record, but I'm confident it's gonna work. One thing I actually found really weird about C#.net is the fact that we have to create a data transfer object for every post request that we're, developing. I don't know if it's a requirement, but I think it's best practice to have a DTO for every post request. If you're a C# expert or you probably know a lot more about C# than me, definitely let me know in the comments if creating a DTO for every push request is compulsory. And if it's not, is there a different way you could develop a post endpoint and get the data from the post request without having to create a DTO? Definitely let me know, because I found that very strange, because in Java, you don't have to do anything like that. You can just, get the payload or the data from the request just by getting the request object, right? Same thing, PHP. Same thing with Node.js as well. But why do you have to do this in C#? It's just so weird. I mean, I don't see it as a problem, but I just find it very weird. But yeah, this is what the code is looking like. Over here, we have our verify token endpoint. So it's going to be /verify token. Then we have the verify token function. This is the DTO I was talking about. So I had to create this verify token request DTO, which is all the way down here. This just basically tells the post request what data to expect. So it's going to expect an email and a token. So if I go back up here, so I'm basically getting the email address from the request.email, the token from the request.token. And over here, I'm basically getting the hash token that is stored in the database for this email address. I'm ordering by descending based on the ID, getting the first or default, checking where the email is equals to the email we got from the client. This just basically returns the token that is stored in the database for the email we got from the client. Once we get the token, we make sure the token is not null. If the token is not null, we then check if the token is expired. So we're checking if the expiration date in the database is less than the current time. So if it's less than the current time, it means it's expired, right? So if it's expired, we're just going to remove that token from the database, save our changes, then send a 401 response back to the client saying the token is expired. Down here, we're creating a Boolean that says token match. And this is using the bcrypt library to verify to make sure the token, which is what we got from the client over here, we're making sure the token and the hash token we got from the database are the same, right? So if this returns false, so this here basically makes sure that the token we got from the client and the token that is stored in the database are the same thing. So if this returns true, so we're checking if token match is true, it means that the user is verified. So we go ahead and remove the token from the database because we don't need it anymore. We save our changes and we send it 200 saying the token is verified. But if this returns false, it means our user isn't who they say they are. So we just return a 401 response saying invalid token. And here we're returning 401 invalid token if we don't find any hash token in the database. I know that was kind of a lot, but I actually hope that makes sense. So we're just gonna go ahead and test everything we just did. To test this out, we first have to send a token. So I'm going to create a send token request. Send this, I should get success. Yeah, token was sent successfully. Bam. And if I look in my inbox over here, we can see we got the token. It's 20924. And this email is being sent by Amazon SES, by the way. So if we go over to Postman and create a verified token request, this is the endpoint we just worked on over here in .NET. So if we go ahead and create a verified token request, we're going to send the email, which is my email address. This is the email we send the token to. And the token I got in my email, it is 20924. Well, first of all, let's actually put in the wrong token to see if it actually fails. Yeah, so we got invalid token, so it means it actually worked. So that is actually good. So let me go ahead and put in the right token, which is 20924. 20924, cool, send. Yep, we get token verified. So it works. So yeah, the verified token endpoint actually worked. I'm actually glad it worked. So we're gonna go ahead and work on the resend token logic. That is actually going to be very simple, just because it's exactly the same as, sending the token. But like I mentioned earlier, the only difference is that we're going to delete the previous token that was already stored in the database. So that way, when we're verifying the token, we're not verifying the token against the token that's in the database that the user did not actually get. Then once we delete that, we're just going to generate a new token, send that to their email. And if that was successful, we store the token in the database, then send a 200 response. Again, nothing crazy. This should probably take me minutes. But yeah, let's get to work.
Suddenly, the world I used to know, I see it differently. You woke me from a dream, now here's reality. Baby, baby, you are really hurting me. 'Cause every time you tell me I look good in bed, I'm doing fine. But nothing ever changes. And now I see, baby, you are hurting me. Stuck in repeat. Stop lying. I know you're playing your part, but baby, it's breaking my heart. How could I know? If you don't need me, just let me know when I go. Truthfully, the game that you've been playing felt so real to me. I once believed that you could be my destiny. Baby, baby, you are really hurting me.
But yeah, the resend token logic is done. And like I told you guys, it probably took me about 15-20 minutes to get this all put together. But same thing, we have HTTP post, our endpoint is /resend token. Then over here we have an asynchronous function, just because we have to send an email, and that sending email process is an asynchronous process, so we have to use this async function. And here we're creating an authentication token using the random number generator from C#.NET. We're getting the email from our request over here. Then we're basically getting the previous token that was stored in the database. So we're basically going through our context, ordering by descending based on the ID, then getting the first or default token where the email equals the email we got from the request over here. So once we get previous token and the previous token is not null, meaning that there's actually a token for this email address in the database, we're just gonna go ahead and remove that token and save our changes. And we're just creating our email body over here. Then we're awaiting the email services from Amazon SES using the send email async function. We're passing in the email address we want to send the email to, which is the user's email. We're passing in the subject, which is this, and the body of the email, which is this. I'm actually going to work on creating a more stylish email body. This is just so basic. Like, this is what it looks like over here. Like, it just tells you your verification code and the code. That's all it does. So I'm actually gonna try to design something that looks more stylish. But yeah, once we send the email, we are creating a hash token string, which basically stores the hashed version of the authentication token we generated up here. We're using the bcrypt library from C# to basically hash that token, so that way when this is stored in the database, it's stored as gibberish, so the human eye can really understand, or the human brain can really understand what it is. And we're basically adding this hashed token to our database alongside the user's email address, and also setting the expiration to expire in 15 minutes. And once that's done, we're saving our changes and we're returning a 200 response back to the client saying the token was resent successfully. So again, nothing crazy. What I'm going to do to make this work is I'm going to go ahead and request a token. So I'm just going to send, we should get, actually I need to start my application again. So if I go back to Postman, close this. I just have to request a new token. I should get success. All right, so we have our token sent. This is the initial token the user is going to request when they load the application, or when they first try to log into the application. Then let's say for some reason I didn't get the email in my inbox and I want to resend the token. I just have to hit the resend token endpoint and pass in my email address. So once I hit send, what's going to happen is that it's going to go into the database to look for if there's any token that matches my email address, which it's definitely going to find because I just requested a token like a couple seconds ago. Once it finds that token, it's going to remove it, save the changes, and generate a new token for me over here and send it to my email address. Let me go ahead and hit send. Cool, so I get token resent successfully to my email address. And if I go into the database and refresh real quick, I should only see one record for my auth token, and this is it over here. And you can see what I was saying, this is the hashed value of this token over here, 58167. It's basically hashed into this, right? And it has my email address over there. So yeah, that actually worked. So what it did was it went into the database, it found a token that was stored there previously, it deleted that token, then it went ahead and sent me a new token into my email address and stored that in the database and sent back a 200 response to the client saying the token was resent successfully. But yeah, that's everything we worked on in today's vlog. I would actually love to make this longer, but I'm trying to keep this probably under 15 or under 10 minutes if possible, just so it's easier for you guys to watch and actually follow along. But I'm definitely going to continue this vlog and kind of like continue the process, since most of you guys already invested in this, right? So it's only good that I continue making this and just like take you guys along the journey. But yeah, all we have to do now is just deploy this version to a V2 domain and update the client to use the V2 domain. That way, the rest of the application is still running on the regular domain, which is linked to the PHP backend. So that way, authentication is functioning on .NET and the rest of the application is still functioning on PHP. And so that's probably what we're going to be doing in the next vlog. It could be something else. I don't know. Something might come up and I will probably not touch this application for the next like 2 months, but I hope not. Fingers crossed, I hope not. But yeah, I guess I'm pretty sure that's what the next vlog is going to be. If it's not, then it is what it is. Don't forget to like, share, subscribe, you know, all those fun stuff. And get yourself a LaCroix. This thing is goated. Like, this thing is goated. Like, just get yourself a LaCroix, man. But yeah, thank you guys for watching. I will catch you guys in the next one. Peace out.